In this video, we want to take a look at what we call piecewise defined functions. These are functions that are going to have a different rule or formula for different parts of the x-axis or different x values. So we're going to have to pay attention to where our x falls in those rules in order to figure out which formula to use. So I have one here that has three different rules for three different sets of x's. So if I have x is less than or equal to 0, I'll use the formula x squared. If my x is greater than 0 but less than or equal to 2, I will use this simple rule where the answer is just going to be 4. And if my x is actually greater than 2, we're going to plug it into the third rule that is x minus 1. Right? So if I have f of -3 and I'm told to evaluate it, I ask myself, which of these rules does that line up with? Well, -3 is less than or equal to 0, so we're going to use the first formula and work it out. Then the next one I have here is f of 2. All right, so that's a little tricky, right? You have x is less than or equal to 2 and you have x is greater than 2. Well, it is precisely 2, so I'm going to have to go with this one that says it's less than or equal to 2. I look over here, it's very simple. The answer has to be 4. Scroll down and do one more here. What if I have f of 5? Well, 5 is not less than 0. It's not between 0 and 2, but it is definitely greater than 2. So when I know that that's where my x falls, then I know this is the rule I plug it into. So the 5 minus the 1 is 4. Let's take a look at another one. All right, so once again, I have three different rules for three different situations of x. I would encourage you to pause for a moment here and see if you can answer these four f of x's. I'm going to give you the answers now. So if I have f of -4, that's definitely, -4 is definitely less than -2, so we have to use this first rule, and we plug the -4 in there, and you should get the answer of 12. If I have f of -2, I look here and I'm like, well, no, it's -2 is not less than -2, it's -2 is less than or equal to -2. Yeah, that works right there. So it fits in this middle formula, so we plug the -2 into this formula, and we're going to get a final answer of 4. Then I have f of 4. Again, that's at that break point, and I have to decide which one to use. Once again, I'm going to choose the one where it's got the or equal to, so we're still going to use, for f of 4, we're still going to use this middle rule. And when you plug in the 4 there, you should get a final answer of 7. Then my last one, f of 6, that's definitely greater than 4, so we'll use the last formula that we're given, 10 minus 2x, and when we plug in there, we get a final answer of -2. So we want to be able to evaluate these, and we want to be able to graph them. So here I have a kind of simple one. I have a two-part formula, and they're both linear, plain x's. So it's broken at 0. It says for x less than or equal to 0, we'll use -1/3 x plus 2. If x is greater than 0, we'll use x minus 5. So I'm going to take this top one and remind myself that it's x is less than or equal to 0, and I'm going to make a table. So I am going to use 0 because that's where it breaks. You notice I put a little solid dot here. That helps me remember that that's where I'm going to get a filled circle. So I put in a 0. The next number I'd want to try is a -3. Why not +3? Because I'm dealing with x's that have to be less than 0. Why 3 and not -1? Because I'm looking at the denominator here and I want to use a multiple of that so that I get nice answers, integer answers to graph. And then just for good measure, we'll try -6. Plugging these into this top formula, you should get a 2, a 3, and a 4. So you see on my graph here, I graphed 0, 2, -3, 3, and -6, 4. It's a half line. It just keeps on going to the edge, but it doesn't go to the right because that formula is only for x's that are less than or equal to 0. Well, what's the rest of the graph look like? Well, for the rest of the graph, we have to use a different formula. So when x is greater than 0, we're using x minus 5 as our formula. So I'm going to start with 0 again, but this time I put an open circle there because this is a strict inequality. This is just going to be a placeholder for me. then there's no fractions, so I'm just going to use easy numbers, 1 and 2, and plug them in. So I get 0, -5, 1, -4, 2, -3, and that makes a line going the other direction. So it's a broken piecewise function. Sometimes where you break on your x's, sometimes those actually line up and connect, and a lot of times they don't. Let's look at one more that's not all linear. So this first formula is an x squared, so I know that's a parabola shape. That's for x is strictly less than 0. So I'm going to have an open circle. And then I have 1 minus x for x is strictly greater than 0. That's also going to be an open circle. So it's not defined, this particular function is not defined for the value of x equals 0. So when I have x squared, I'm going to go ahead and make my chart again. I'm going to start with 0, and I remember it's less than 0, so I'm going to go to -1, -2, -3, plug those in and get some ordered pairs. Then I'm going to come over here and plot. I can't do the -3, 9, but that's okay. I've got enough to get the shape. Then I take this other rule and remind myself this one I'm going to use the positive x's, and I put that into the formula, the 0, the 1, the 2, and this time I get a line and it goes down to the right. Let me know if you have any questions.